Today we're going to take a look at the distributive property. The distributive property looks kind of confusing when you first start looking at it, but once you get into working some problems out, you're going to see that it's really not all that bad. The idea behind the distributive property is that we have something that is being multiplied to a set of parentheses. Now, inside of those parentheses, we can either have something being added or subtracted. It doesn't matter which. And what it allows us to do is, instead of just saying we've got the thing on the outside, which in this case is A, being multiplied to the group of parentheses, we can break this apart and get rid of the parentheses. And we can multiply A times B to get AB, and A times C to get AC, and they would still be added. Down here, we would have A times B to get AB, and then minus AC. And what this does is it allows us to go ahead and work this out and get rid of the parentheses. Now, one of the first things I like to do is to show you that the distributive property actually does work. And what we're going to do is we're going to use numbers. So we're back to numbers for just a while. And we're going to prove that this works. Now, the first thing we're going to do is work out this same problem. You can see we have the same problem here using PEMDAS. And so we're going to start off with parentheses. So the first thing we do is combine what's inside the parentheses. So 2 plus 5 is 7. So we have 3 parentheses 7 minus 3. Then we're going to take this and do multiplication next. So multiplication would mean we do 3 times 7. Well, 3 times 7 is 21 minus 3. And then we can do our subtraction. 21 minus 3 is 18. Now, we're going to take a look at the distributive property and show that you get the same answer if you use the distributive property. So we'll start off multiplying 3 times 2, which is 6. And then 3 times 5, and we're going to add 3 times 5, which is 15. Once we've done that, now we can go ahead and do our addition and subtraction. Well, 6 plus 15 is 21, and 21 minus 3 is 18. Now, a lot of kids, whenever they see this, they turn around and say, well, I'm used to PEMDAS. I'd rather use PEMDAS. Well, personally, on this particular problem, I'd use PEMDAS too. So the question is why do we need distributive property? What's the point in distributive property? Well, the point is sometimes we get a problem like this. Now, if I try to use PEMDAS on this, the first thing that we have to do is parentheses. But I can't. I cannot combine 3x minus 4. So now I'm kind of stuck. Well, distributive property allows me to get rid of the parentheses so that I can continue on with the problem. So what we're going to do, and you'll notice I always draw what I call mountaintops. Now, the reason why I call these mountaintops is because mountaintops starts with M. And mountaintops mean to multiply, but this is called the distributive property. But I draw these mountaintops, and it's pointing to the 2 and the 3x, that first one is. And so I'm supposed to multiply 2 times 3x to get 6x, and then 2 times negative 4 to get a negative 8, and then I'll bring down the plus 2. Now that I've gotten rid of those parentheses, I can go ahead and continue combining like terms. So I can combine, let me switch colors here, I can combine my 8 and my positive 2, because those are like terms, and get a final answer of 6x minus 6. We cannot combine the 6x and the minus 6, and that was what we talked about in combining like terms. So this right here is my final answer. Take a look at a couple more problems, and you can see here we're going to have to apply the distributive property more than once. So I'm going to draw my mountaintops in. And mountaintops mean to multiply, so we're going to get 2x plus 8 for the first set of parentheses, and then the second set, when we use the distributive property, 5 times negative 3 gives me a negative 15x. Now I went ahead and put the negative down as a minus sign uh, just to make it easier. And then 5 times negative 2 is a negative 10, which I put down as a minus 10. So now we can look to combine like terms. So my like terms would be 2x and minus 15x, and then also 8 and negative 10. So whenever we combine our like terms, we have 2 minus 15, which gives me a negative 13x, and then 8 minus 10 gives me a negative 2. And so I cannot combine the negative 13x with the minus 2, so that is my final answer right there. Looking at the last problem, we'll do mountaintops on both of these. Now this second one looks kind of tricky. We just see a minus sign, but there's something in between the minus sign and the parentheses. It's an understood 1. And so I'm going to go ahead and put that understood 1 right there, and we're going to do mountaintops. Okay, we're going to distribute the negative 1 to both things inside the parentheses. So going back to the beginning, 3 times 2x gives me 6x. 3 times negative 1 gives me a negative 3. And then we're distributing the negative 1. So negative 1 times 3x gives me a minus 3x. And negative 1 times 6 gives me a positive 6. And this second mountaintop that I just did is where a lot of mistakes happen. A lot of kids will just look at the negative right here and put a minus sign down there. But this is negative 1 times a negative 6, which gives me a positive 6. Now we can look to combine our like terms. So we can combine 6x with a negative 3x, and we can combine a negative 3 with a positive 6. So 6x minus 3x gives me 3x, and negative 3 plus 6 gives me a positive 3. And once again, at that point, we are done with the problem. And that is how you use distributive property, and also why you use distributive property.